Hey guys, welcome back to AlgoYogi. Now we are doing stack series, and our next problem in the list is implement queue using stacks. And if you remember, right before this problem, we have implement stack using queues. So if you haven't done this one, please check it out. I'll post the solution right over here. So if you're seeing this video, you will be able to see the solution over here, or you can just check it out on the AlgoYogi YouTube page. Now, let's solve this one. Let's implement queue using stack. So implement a FIFO data structure, which is first in, first out. Queue is a FIFO data structure and stack is a LIFO data structure. Last in, last out. Last in, first out, sorry. Not last in, last out. So we need to implement first in, first out FIFO queue using only two stacks, and we will need two stacks. You'll find out why. The implemented queue should support all of the functions of a normal queue. What are those functions? Push, you push an element. Peek is you basically peek the first element which is in the front of the queue. Pop is you pop the first element which is in the front of the queue and then check if the queue is empty. So we will be implementing all these functions. You are already familiar with these functions. Same functions exist in stacks. We have implemented them in our previous problem while we were implementing stack using queues. All right, so and these are some of the things that they have given us. You must use only standard operations of stack, which is pop or push. And basically checking the size, top is empty, operations are valid. Okay, depending on your language, the stack may not be supported natively. You may simulate a stack using list or dequeue or whatsoever. Yeah, but like we are using Python. Python has, this array could be used as stack, and we will do it just like that. Okay, so I'm gonna switch the view here. Let's understand what are the properties of queue and how it differs than stack, and how we will be basically implementing the queue properties, those functions that we need to implement: push, pop, peek, and empty, using the properties of a stack. So if you remember, we were just reading it out. Queue is a FIFO data structure. What does that mean? That is first in, first out. And let's say if this is my queue, which is 1, 2, 3, and 4, and I need to pop something out, that means I need to get the element from the queue. So if I were pushing the element from the back, let's say if I want to push 5, I will append that to the end of the queue. So that will go right behind 4, right next to 4. So this is where we will push 5. But if I want to pop something from here, I will be popping out 1. Because this is the front of the queue. This is the front of the queue. We pop out the elements from the front of the queue. So this is front of the queue, and this is the back of the queue. Now we basically push in the back and pop from the front. So we will be, if I want to pop out something, that will be from the front, and if I want to push something to my queue, that will be in the back of the queue. But that differs in stack. In stacks, if I wanna, it's a LIFO data structure, which is last in, first out. So let's say if I have this as my stack, and I'm pushing some elements onto my stack, it's gonna go like 1, 2, 3, and 4. And let's say if I want to push 5, that will, just like queue, will go to the back of the stack. So right here I will be pushing it. Okay, so now you can see this is where I will be pushing it. But if I want to pop something out, that will also happen from the back of the stack. So if I want to pop something out, so I will be popping 5 out from here, and that's what I will be returning using the pop function. Now we understand what are the differences between queue and stack, now we need to implement FIFO using LIFO. Basically, we need to implement queue using 2 stacks, and they have given us like stacks, exactly 2 stacks they have asked us to use. And let's see how actually we are going to do that. Now we understand FIFO and LIFO. Let's talk about how we will be implementing. So the only problem that you see is when we are using a stack, so we are going to use 2 stack 1 and stack 2, and I think none of them is going to be a primary stack or secondary stack, but like for reference, let's say whenever I'm pushing something, I decide to push onto basically my stack 1. So stack 1 is over here, stack 2 is over here, and let's say I need to implement the push functionality of the queue, which is simple. Just take the element and push it into the data structure. We are using 2 stacks. So first what I'll be doing is pushing that element. Let's say it wants to push 1, so I'll be pushing it onto stack 1, and that's it. Now I have that reference to that element. So let's say it again wants to push 2, so I'll be pushing it to my stack 1, and let's say it says push 3, I'll be pushing it to 3. So push works fine. How about pop? Now if you see, pop should be returning me 1. Pop should be returning me 1. But do I have access to 1? Although I do, kind of. It's in the beginning of my S1. But if we have been asked that we can only use the standard operations of stack, which is push and pop, or peek or whatsoever. But like right now, I cannot access 1. So what do I do? I will use pop operations from stack 1 to push things to my stack 2, and I'm only going to do that if my stack 2 is empty, basically. So what I'll do is I'll take all the elements, because I need to access 1. I'll take all the elements, pop them out, and start pushing to my stack 2. And I'm only doing it when I'm working on pop operation. So I'll just take this element. So let's say I'll take out 3, and I'm gonna push it to my stack 2, and pushing basically shifts things in. And then I'm gonna basically take out 2, and I'm gonna push it to my stack 2. Then I also take out 1, and push it to my stack 2. Now my stack 1 is empty, but my stack 2 has all the elements that were pushed onto my stack 1, but they are in reversed order. So what does that mean? That means what I wanted to access, which was 1, that was in the front of the stack 1 earlier, now is in the back. Now I can do a pop operation on stack 2, okay, and then just return 1, right? That's what I will do. And if I have to again push some more elements, that I will do to basically, let's say I was asked to push 4. Let's say if I was asked to push 4, I will push it to my S1. But remember, this 1 is gone. We have popped this out. Now this is the order that we have in S2 and S1. S1 has this element 4, which was pushed the last. Now let's say if I'm calling peek function. So peek should return me the element that is right in front of the queue. So right now in the queue, if you see, now 1 is gone. What is in the front? 2 is in the front. What is in the back of the S2? Which is like, because we only have access to the topmost element in S2. So this is 2. So this is what I will be returning. Not popping, returning. Okay. I'm not popping it out, because peek is, it just returns the front of the queue, just the element it returns, it doesn't pop it front. Now the peek, we have implement push, we have implement pop, we have implemented peek, and I think now we have empty function left that we need to implement. This operation will be basically checking if we have elements either in S1 or S2. If they don't, then return true in empty, otherwise return false. And let's say a few more things. If we were to pop again something from the queue, so if I wanted to pop more elements, right now S2 in the front, so I will pop basically from S2, and I will, let's say if S2 I keep popping, if I keep popping and I pop 3 also, now my queue is not empty, there is still 4 which is in my S1, but if I see my S2, it's empty right now, it's empty. So what do? I will, if S2 is empty, I will again do that operation where I start taking elements from the from my stack 1 and basically keep accessing the topmost element and start pushing. So right now these are, there is only one element which is 4, so I will take 4, and then append it to my S2. Now S2 has 4, and if I wanna basically pop element from S2, then I will just pop out 4. This is what I will return. So now we can see that we can access elements in average big of 1, or I don't mean to say access, we can pop element. Push is happening in big of 1 time complexity. Pop is kind of happening in big of 1, but like on average big of 1. But there are cases when S2 is empty, then I basically take all of these elements, and there could be basically, if all the push operations were all together, then it would become big of n, but on average it will be big of 1. It could become like worst case big of n operation, but on average I think it will be big of 1 because I will be popping out from my S2. Then peek could be also if my S2 is empty and I had to peek, and I had to basically take all the elements one by one and push them to my S2 one by one like this in this order, and then I will have to peek this element. Then also it will become worst case, peek will become big of n, but on average it will be big of 1. That's it. Empty is also big of 1. So all most of them except pop and peek, all the other are big of 1 time complexity, which is constant time complexity. So let's go ahead and implement this solution. It's quite easy. But I'm sure like you to find it easy, you have to solve it beforehand. Otherwise, like you kind of get stuck in this loop where how do you make the decision to basically start popping from stack 1 and pushing to stack 2. Okay, so I will have S1 my stack 1. We're gonna use simple list, and S2 will be my secondary stack. Now if I'm getting an element X, I will be basically, if you remember, we will be pushing it to stack 1. So nothing to do here, just self.s1 dot push the element to my stack 1. Now pop needs to return S2, and by the way we don't have to check if S2 if there are elements or not. They have guaranteed that if you actually read the constraints, they said like pop will only be called when there is at least one element, so we will have something to return. So S2 dot pop, we could just do that, S2 dot pop, or never forget to append the self keyword. So if not self dot s2, if not s2, then what I want to do is while self.s1 I want to append to s2 self.s2.append. What do I want to append? I want to append the elements from self.s1.pop. Awesome. Okay, I hope this definitely makes sense. And now finally from s2 we just return. So this is where we are popping all the elements from s1 because we didn't find anything in s2 to return, because we need to pop an element, but we didn't find anything in s2. So what do? Take any elements, and I think at least there will be one element in this case, because we were promised that there will be at least one element to return if pop has been called. Otherwise it will not be called. Okay, so it will return the last element from s2 because all the elements from s1 have been appended in reversed order so that we can access the front of the queue. We are implementing queue here, right? All right, peak will be same, except just little one thing, that instead of popping from s2, we just want to return the element. We're not popping it, we're not deleting it from our s2. We are just checking what is the element in the front of the queue and back of the s2. I hope that was clear from the conceptual part. Now what about empty? Return self.s1. I think let's check the length self.s1 equals to 0 and len of, या तो win है या learn है win है या learn है okay, so s2 this is also equals to 0, and yeah, I think that's it. I'm just like to make it look little nice, I'm just doing this. So remember, this is it. We have 2 stacks. Keep pushing to stack 1 if you want to pop out from s2, but if s2 doesn't have anything, then pop everything from s1, and in that reversed order push it to append it to s2, and then same thing in peak. Don't pop it out, just return the element. And to check if our queue is empty, that means we don't have any element, so just check that our s1 or s2 do not have anything. Its length is basically 0. All right, I'm gonna zoom out. You guys can have a little nice peek on the code. Looks pretty good. Simple implementation, and we will write down time complexity first. Let's run it and submit. Not awesome. That is because we don't have push, we just have append in basically in whenever we are dealing with these arrays. So we only have append, not push because push is what exists on stack. I'm not using stack, I'm using this simple arrays or list, whatever you guys want to call it, and you should do it this way as well. Okay, I am going to run it unless you're using some other language. Awesome, 100%. So let's write down push time complexity. I'm just going to write time complexity here. So let's say time complexity of this will be big of 1, average case. This one will also be on average, but worst case would be when all the push are all together, and we have to basically pop everything out from s1 and push it to s2. So that will be basically big of n. N is the number of elements or operations, whatever, push, pop, or number of elements basically in our queue. This is going to be same, and this is going to be big of 1. So I'm gonna delete this. All right, this is it. So now space is basically n, and also I think that's the space is about the queue and not like individual functions. All right guys, let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then, bye-bye. Bye-bye. Bye-bye.